fact is, he's like, what, at least 5 years older than the other one.
Yes, he goes so defensive.
He does, exactly, because...
Stop gossiping, it's live.
That's alright, you're right, Jordan, I'll say it to you.
Okay. Yeah, but some enemies of Jordan might be listening. Okay, I've created one special one with an extra sheet for notes for you.
And do you know what? Thank you so much for stapling it, because I haven't got the stapler.
It's a
But
I
I
discovered now that some defenses can say.
Oh, yeah, but the ones where you don't have access to.
Oh, you do have it.
More so, yeah.
Actually, the one of them is downstairs where the old entrance was like a student hub is, and
It doesn't matter, because if you put the settings in,
still doesn't staple.
I've
Even
tried.
on that printed down.
I have tried to get free staples.
Okay,
There's no
well,
Wi-Fi.
I don't know. Why is there no Wi-Fi? Because I've stolen it.
Yeah.
I was just trying to connect to MSD across the
All right. So, aggregate planning. So what do I do?
Sit there.
So how does it?
How much gig it will be. Why don't you just call IT now so you can fix it?
Because that would take too much time. And we only
You just be
need
stubborn.
and we only need it for this homework solutions and the other thing is Christian work. What I'm going to do is I'll take last year's solution because homework doesn't say that. Rather than
I just went, oh, it's normal again.
rather than writing upside down.
That's the old.
Okay. The homework question was to add hiring and firing of workers to the bicycles example, I think.
Mm-hmm.
Okay. The homework question was
Hello.
Sorry, it doesn't work on my phone, so I was wondering if it worked on my tablet.
There's some good full grade.
The problem with it is that I don't know. It sounds odd to listen to yourself.
Not as well as Philip, if you're watching this, I'm joking.
Okay. He might be listening.
Alright. Hey, up here.
Hello. It worked.
Somebody's going to edit it all these out.
There's too many screens. Too many screens. I don't know. Okay. It basically follows the pattern that we did in the theory bit in the lecture, so there is nothing much to talk about. Just to realise that you've got these two parameters which tell you how much your hiring workers costs and firing workers costs, and then you need additional decision variables for the number of hours hired and fired in every period, week or month, whatever. And is Jordan listening? Jordan, are you there?
I don't know, I can check the live chat if you want.
Just leave it on mute.
No.
How do I access the chat on here?
Okay, so the objective has all the cost elements as we had before, but there are some two new components of the cost. And there is a new constraint, well, a set of constraints really, one for each period, that are the continuity constraints for the work time. So, and obviously to the X continuity, we have worker hours from previous month, plus hired hours, take away sacked hours is worker hours in next month. Okay. Typically, the overtime constraint becomes something like this, where the maximum amount of overtime you can order the workers to work for is some proportion of the actual hours available. In normal time,
That's how it looks now.
okay.
That's all.
We will typically have some initial condition at the beginning, and that's basically everything.
Oh, I've just answered. Can you go up a bit? I can't see what it is at the top.
That's the 8.5 in episode 1.
Wait, what do you want?
Just
Down,
no,
up?
no.
I don't know.
You're down, my up.
Okay, my down.
Towards you.
No.
That
Okay.
way.
Yeah, I just need that page.
Yeah, okay.
It's like if Jordan the homework answers.
Oh, you're saying Jordan was more.
I just like write them now, so.
Because this camera is better than the one on my laptop.
You should recommend it to John Shear, because his PDs are recording really bad quality.
It only works with a Mac. It works with Apple stuff only for some reason. Just the manufacturer decided that Windows and other operating systems are not.
That constraint at the bottom.
Which one?
The OT.
That's 1/4. I mean, it's not very well.
Yeah,
legible.
I'm just saying that constraint's required in that as well, isn't it? With the 2 extra ones.
By that you mean the assignment?
That's
Yes.
the second one.
It's one of the extra questions, I think.
Yeah, it's in the middle bit, some of that.
Yes.
But yeah.
Yeah.
I was wondering what it was.
So except that, so
Slightly
you have
different.
0.2 times, you have 0.25 times.
Well, no one's replying to my message in the live chat.
No. So I'm slacking on taking marks for the homework. So Callum, you've done 1 or more.
2 with that one.
Okay.
I did.
And Mary, you've done 2 as well, so at least 2, not 3. Just 2, yeah? I mean, overall, for in the 3 weeks. Not today. Today. In the 3 weeks, you've done 2. Okay, thanks. I'm just a bit thick.
That's not very reassuring. You teaching us?
No, but that's what you get.
No.
If you pay $9 grand, you get me. If you paid 25, you get someone at MIT.
If I can complain enough about E,
Well, he like.
get out of this room.
Yes, he actually did. Only. Yes. I'll mute the mic.
Who's
Switched it off because of E. He might be listening.
no one's on it but me, Callum.
How do you know?
Because I'm on it.
And does it show how many people are there?
Yeah.
It does.
Wait, does it say 3?
No, that's 3 subscribers.
Oh, it said 3. You can only see it when you're on the, you go into the YouTube live stream thing. You can see who's watching and where.
What's it called on YouTube?
Yeah, I'm
just
on it.
literally with these amazing.
Right.
Jordan was active 27 minutes ago.
I've done this before, so I'm a bit bored by this topic.
Is that because you teach 3 years of it, or?
No, but this particular one I've taught 3 times. Do something else next year.
You just go, it's not.
You're now at 4 subscribers instead of 3.
Oh,
Who's
thank
the
you.
third? Is it you?
No.
Who's the second?
Me and Jordan.
I was married, probably.
You must have one from another year.
So it could be someone from the first year, second year.
God bless them, you know.
There's someone in the second year who's watched the whole lecture, the whole 50 minutes.
You can see if we've watched it all.
You can see.
Yeah, well, if you see that there's
Watch it for how
one
long.
view on a particular day,
And it says
lasted
50
for and the average length duration is 47 minutes. Hello.
Sorry.
Just in time.
How do I do
We're talking about rubbish only today.
That's a good question.
We were chatting to you on the chat, hoping you'd see it.
No, I think it.
So, I mean,
Oh, that was cool.
I figured it out.
why are you sending kissy faces you don't do?
It wasn't. They are sunglasses.
In fact, I could put probably put that camera and that camera side by side, so it's showing my face. Anyway, this is a MIP model. I'm assuming you've read the rest in the meantime. We're in a situation which is somewhat similar to inventory planning from the first year. Do you remember that?
Yes.
Yeah, exactly. The
Yeah.
chainsaw. Except here, it does belong in roughly in the same area, but the difference here is that demand is no longer constant. Okay, so here we assume that we know the demand; it's deterministic and known in advance, but we're not assuming that it's constant. So when we have periods to be weeks or months typically, and we are assuming that we know every month how much people are going to want, but it doesn't have to be the same amount all the time. And it applies to ordering just as well as to producing the product at hand. Okay, well, you can see what it is. I think you've read through it. I won't read the slides because then I'll get nasty comments in ISS that I'm just reading the slides. But actually, usually other people get those comments. But
I think we'd just like to see that.
okay, MIP. Do you know what a MIP means?
Inventory planning, something.
Anybody remember MIP? Mixed integer programming.
Oh. Let's get simplex out, guys.
No, they will be branched and bound.
Easy marks.
Okay, so
If the question is even written right.
mixed integer means that some decision variables are integer and others are not. Others are just real. Example is here, which you also have in this. Come on, I said here. Okay, what have we got? We have different demand in every week, and the cost that there are, figure in this model, is storing, stockholding, which is just the same as we had in aggregate planning, similar concept. So we'll be modeling it as the number of magnets we have at the end of the week times 90 pence. And there's this setup cost, or it was ordering cost when we were considering ordering. So no matter how many magnets you make, because you have to tweak the machines that they're made on, set them up, you get a certain cost. It's approximated to be £100 every time you create magnets. And then you have manufacturing cost of the magnets themselves, but it doesn't matter in which week you manufacture them. The cost is assumed to be the same, so you don't have to consider it for the model. to find the optimal solution, when to produce and when not to produce, you don't need to know the direct manufacturing cost. If it was different in different weeks, then you would have to add it in, but we're assuming that it's the same. And there is a limit of how many magnets you're able to produce in a single week. Okay, the situation clear?
Yeah.
Good. So on to the solution. Yeah. So just to summarize the parameters that we're given on the data, we had a time horizon, which you probably know what it is because you answered that in the quiz, hopefully.
You might just do that.
So in our case, it was periods 1 up to 10, because we had 10 different weeks. And we know the demand, Q sub T. So that's the demand in period T, for all T in the time horizon. We have stock holding cost, which is per unit of production per unit of time. So in our case, it's G is 0.9 pounds per magnet per week. Okay, and we have the setup cost. So this was £100 in the example, and we have some limits. So this is maximum production. Which in the example was set to be 60 magnets. Okay. I think that's everything from it's all the data we had in text. So a typical formulation starts with
After this lecture, will we be able to do the batch planning?
Yeah, you should be able to,
Sure, it's very big.
provided we get to the end of this lecture. In this lecture. Okay, so the decision variables, there are 3 sets of decision variables. Any guesses? Educated guesses?
No, I'm a graduate.
So there are 2 sets that are the same as they were in aggregate planning.
Hours.
Not hours,
It's
in fact, but because
It's weekly.
yes, weekly, but weekly what? Weekly production. So that's the amount of production
produced.
in week T.
Is it stock problems?
And yes, the inventory level or stock, whatever you want to call it, at the end of the week.
And then capacity one.
What's the constraint?
Or whatever number of magnets in storage at the end of week 2.
Yeah, that's exactly this.
Okay. Sorry, I thought you said something else.
So I call it inventory, but. Okay, today are familiar. What is new is the integer thing. What's so funny about it?
Just thinking.
And the integer thing I'll call delta, which will be actually a 0, 1 thing, also known as a decision variable, which is going to be 1 if the setup, or if we set up in that particular week. So if setup and production done or carried out in week T. Zero otherwise, of course. Okay, that's it for decision variables in this model. All good. Objective.
Don't miss costs.
As Jordan is saying, minimize cost. Give me a formula for the cost.
So.
And then T equals, belongs to T.
Yeah, you're getting good at it. Of.
Just keep flipping that. XT.
Yeah.
Multiplied by, I'm guessing A.
No.
What?
Why would you?
Just
It's
so.
not XT, sorry.
Is it not? Amount of production on a week.
I'll go back. But there is no, so, okay. The joke.
It's got to be 8 plus something.
All the 3 costs. Stockholding cost. Okay, so the stockholding cost is
G times IT.
Yeah.
G times IT. That's right. Setup cost.
Plus A.
Yeah.
But it's got to be A times delta T.
Yes.
Uh,
So if in a particular week you're doing the setup, the cost is A. If you're not doing the setup, the cost is
And
0.
there's no cost.
And then there's no more cost. There could be, like I said, if the production cost was different from week to week, depending on, I don't know, some outside factors, then you could have that cost there added as well. But because we're assuming that the cost is the same in every week, we don't have to add it there. It won't
Right.
change the optimal solution. Doesn't matter in which week we're producing, the amount we're producing in the end will have to be equal to the total demand over the 10 weeks.
okay.
So we're not producing any extra just because we can. And yeah,
It doesn't factor in the stock holding costs for things that are made and then sold, does it? Because it just says
Yes.
at the end of the week.
yeah, that's an approximation of the actual stock holding cost. The kind of thing. You could make it a bit more complicated, or it would be too complicated, and
No, that's legal.
and the result would be Yeah, they're good enough like it is in practical terms. So no need. Okay, constraints.
XT.
N has to be less than 6.
No,
No,
M
M
is
is
60.
Oh, sorry, XT has to be less than that.
XT has to be less than 60 in each
Or equal to.
T. XT has to be less than 60, which is M. Okay, we'll come back to this.
I feel like there's something missing from it. Because you've got to do,
Integers.
it's to do with the inventory of the model. So it's like IT minus 1.
Oh, yeah.
Also, we want continuity.
Yes.
So there's always the same continuity in these models.
Isn't it?
IT minus 1 plus XT.
Yeah, go on.
Would be equal to QT plus IT.
That's the standard form of it.
So, yeah, I'm gonna get that now.
Okay. Any more constraints?
Integer.
Yeah.
It's getting up. Stuff.
It's alright, no matter how many times we do this integer thing, I never remember it.
Well, I do remember it, but
I also say you didn't. No need to get defensive yet.
Formulation on the equitable funds.
especially since I had it good.
Anything is better than simulate.
That's good. The equitable planning one's got
Okay.
3 variables.
Anything that's missing there?
We don't
He's
have
waiting
a
for one of us to
constraint.
say yes.
We don't have a constraint for how much we can hold, but it's not like it mentions it in the question.
Yes,
Is it
so
something-
that's a good good remark. If you had a limit on how much you can store in inventory, you'd have an additional constraint, IT less than or equal that limit. But we don't have that in the example, so we're assuming that we can hold all the magnets that are needed for the 10 weeks. So we could just make all of them in the first week and then keep it if we wanted to.
Question. Could you not merge the XT has to be greater than 0 with the XT has to be less than that?
Yes, you could do.
Okay.
And you should have a quantifier as well, that it's constrained in every, I'm being lazy, so in every time period. But there's something fundamental missing there. And the fundamental thing that's missing there is that you could, as it stands, you could just set all the deltas to 0 and still produce, because there's nothing stopping you here in the constraints from producing delta 0. So that would minimize the cost, obviously. I can tell you what the optimal solution here is. Delta is always 0, this is always 0, and XC is exactly equal to the demand in the particular week. But that's not the point of the thing. So how do we prevent that from happening? How do we make sure that we only produce in the weeks where it's telling us, it's XT, it's telling us to produce something only in the weeks where the setup cost is accounted for? Somebody have an idea?
You say like the sum of the delta has to be above 0. Maybe delta 2.
Because you just waste one delta, wouldn't you?
So
Just one delta.
QT.
No, if you just made it.
I didn't get that, but it doesn't matter. I'm told.
I was just putting out before and the answer. So I'm guessing here a batch is 60 magnets. cells.
at most.
Um,
Make
So-
30 if you want.
Okay, so no matter what, it's the same price.
Yes.
Okay.
So it's always £100 to set it up, because it's not the cost of actually doing it, but it's the cost of setting it up before you start producing. So, you have a machine that makes something else, and then you have to tweak it so that it makes these magnets, and then afterwards it's going to make something else, for example. Yeah. Or if it's all, that's the idea. It's like that, many.
You've just got to do M times phi delta T
Where?
on the right hand side of that constraint.
Which one?
The top one.
Yes. Have you been cheating?
Yes.
Yeah, so if you put M times delta T, then this constraint does two things at once.
Our production per week is less than the maximum production of the week.
But because you define xt as greater than or equal to 0, it means if that's 0, that can't be anything at all anyway.
So if delta T is 0, so if it's decided that in that particular week we don't produce, this whole right-hand side is 0, so xt can't be positive.
Above 0.
So that makes sure that in the weeks where we're not doing any setup, we're not producing anything. Delta T is 1 though, so that's a week where we're willing to pay for the setup. This makes sure that we don't produce more than the maximum size of the batch.
Mhm.
Okay.
And then obviously the one underneath.
I'm going to ask a really stupid question.
Yes.
So if it's one payment, no matter how much you're making a batch,
Yeah.
then why are we multiplying A by the sum of delta T? Because isn't it just A, no matter what batch we do?
Oh. No, but
It's a
so
sum.
okay. So the sum of delta T is the number of batches
That's
that
every
you do.
batch.
Okay.
Hell, that means
So in every week you either do 0 or 1 batch. And the next week you either do nothing or 1 batch. And the following week you either do nothing or
No,
1
okay,
batch.
okay.
Okay.
Yeah.
And so every week when you decide, okay, I'm making a batch this week, 100 quid, produce up to 60. Okay, next week I'm not doing anything. I had enough from last week. Okay, following week I'm not doing anything. I have enough from 2 weeks ago. Fair enough. Following week, oh, I need to produce now. So 100 quid,
Okay.
delta goes to 1, produce up to 60.
So it doesn't really need to be in the sum part.
Yeah.
Well, the A could be out of the sum, but you'd need 2 sums then. So if you want, you can rewrite it.
That's fine.
Yeah, so this is the same as G
Oh, it's
times
fine.
sum IT plus A times delta T. Is that okay?
Yeah.
Whichever you prefer, they both mean the same.
Whichever one formula is better.
Okay? What do we have?
Can I just apologise? I've been awake since 8:30 last night.
Oh,
That's why I'm very
apology accepted.
a bit worried about my next lecture though.
Not great.
Is that Philip?
Maybe.
Okay. Any questions? No? Good. So we know this. How much time? Oh, good. Good. I need to move this up. Sorry.
Did you finally change your phone password?
No. Do you think I would remember the new one?
I do.
And this video is having practice.
I didn't state what the password was. I can't do it.
I've got some stupid remark here in the notes. I don't know what it is.
Is it a me?
No. It's on capacitated and uncapacitated. None. Okay, so I'll not do it. Extension.
In the homework, my constraint.
Hmm?
In the homework, my constraint.
Multiple products. So imagine you don't have just one magnet. Similar to your assignment, you have a certain number of different types of magnet, and you have to do the setup for each of the magnets separately. Okay, because for each of the magnets, each of the types, you set the machine in a slightly different way. And every time you do that, there's a cost. So suppose
Oh, right. Okay, that was a stupid question.
there are several types of magnets.
Is this going to be like those shoes again?
Shoes. Cinderella shoes.
The princess shoes, the giant shoes, and the prince shoes.
Is the giant going to come and kill you because you didn't make any shoes for him? So P is the set of
Is that a threat?
that's what I tell people to put in the assumptions of the model. So that's an additional piece of data.
You won't use PP, but you tell people to put your assumptions that a giant's going to come to kill you.
No, the assumption is that the giant is not going to come and kill you.
That's even worse.
So now the demand is different for different products. Yeah, so we're not putting them as a different product.
Nice save.
Some sort of a Christian
Religious
thing.
imagery.
Okay, so Q, what do I have to do? QIT, I is the product, so I'm not doing P. T is the week.
It's not even funny yet.
What?
You giggling at PP.
Me? I thought it was you.
Well, first lecture, you had a proper good old giggle to yourself about the word PP.
No, it was about QT.
Not you, Mom.
And I still use QT. AI, GI, it's not my idea, it's some of the students. You see, the students are getting more mature as I progress. 2 years ago, they would laugh at QT. Now they laugh at me laughing at it.
I think they're more like laugh at 420 to be honest.
Setup cost, inventory cost, stock holding cost. Per week. No, it's not per week.
Does that say to stock H?
Of product I.
Yes, I hold.
Thank you.
And yeah, so these are the new data. Now the decision variables. All of them have to be per product. Okay, so you have the 0, 1 setup, you have the amount produced, and you have the number of, or the amount stored for each product in each time period. I'm not writing what they mean because you can look it up in the previous.
This works the same way when you're doing the aggregate planning as well.
This works the same when you're doing the aggregate planning for several product groups. So this is where you're going in your assignment to.
Hopefully.
It requires not solution settle.
The objective is the obvious one. So you have to add everything over all time periods, but you also have to add everything over all products, and everything is, which order do we have it in? G.
Yeah.
GI times inventory of product I in period T plus setup cost of the I thing times whether you do setup or not. Okay. So the objective is the only thing it can be. And what are the constraints?
You tell me.
So the continuity constraints rather.
Question.
Yes.
Oh, it's more for Callum.
Hmm?
You know your ethics form, usually you have to put the back of your project.
Can't wait 5 minutes.
Just let you go keep writing.
Okay, I'll keep writing.
Sorry.
To answer your question, I haven't really got my ethics form yet. But it will be done by someone.
You read it.
I want to get it done for tomorrow. That's the plan.
I spent 8 hours in the library last night writing my terms of reference. It's still not done.
I'm gonna get like a page which doesn't matter.
Well, not much has changed there. You just
Yeah.
have
Just more eyes.
product
It's
groups,
multivariable, isn't it?
the product types separately or accountable separately as well.
Oh, yeah.
Now the setup constraint. Okay, so there are several variants. First one is that the amount you produce of any particular product in any particular month is, there is a certain limit for that particular product, and you have to times it by the delta. So this is the one we had, just I's added everywhere. Something missing there. I in P, T in T, yeah. Variant B is they somehow depend on the same machine. So the total amount you can produce in a particular month is limited, okay? So in that case, so if the total amount you produce in a month is limited, you have to add all the production quantities of product I in period T over all the products, and that is a limit, which is the same, which is not the same, but which is common rather for all the products added together. Okay, so this kicks in if there is a limit on the total production. But now this limit has lost the ability to do the setup as well at the same time. Okay, so the setup, namely enforcing that we don't produce anything in the weeks where there's no setup, that has to be separate now. So for the setup, so in B, need setup constraint, which is that x I t is less than or equal to delta I t times a large number, n. Or it can be the same n.
You just wrote the same with variant name, except without the I. Yeah.
It's swapped around. God damn it, Callum.
It's still the same, except it's a song.
Okay, so that's the same, I suppose. But there have to be two sets of constraints if there is a total production limit, as it is in the assignment.
Is all of I, comma t just a lazy way of giving I belongs to p and t belongs to 2?
It is, yeah.
Okay.
Thanks for the clarification. When you're watching this back, can you find it?
Well, no, because I'm really confused because there's no slides to match with what he's saying. So,
It's the slide. It slides up, it slides down.
Okay. Variant C.
so the homework, do we edit the original problem or the extension problem?
The original,
Okay, thank you.
I think. What does the homework say? I printed it last week and forgot to order it.
In the Croy-Flux magnets example covered in the lecture, what set of constraints have to be given if there's a limit of 50 on the number of magnets?
That can be stored.
Mhm.
Well, that's quite easy.
So do we edit the original or the
Yeah, the original.
Okay, thank you.
Okay. Well, you can do either. It's not very
Rather than
different.
the original.
Okay. Variant C, I'd rather do the extension because you learn more. Okay, variant C is if, imagine that, so you want to do something like variant B, but different types of products take a different amount of the resource that makes the capacity there, okay? So, for example, you have big magnets that take an hour and small magnets that only take 40 minutes. And you have a certain number of hours available on the machine. Okay, so in this case, you would have some coefficients. So you would add over all the products, call it SI, whatever it is, XIT. Okay, so there will be some number for each of the products. For example, the number of minutes or something else, depending on the exact situation. And that is less than or equal to some arbitrarily names of variables, constants.
I'm going to look back on this and be like,
What?
yeah.
Words.
So SI was the amount of hours that it takes, did you say, yeah?
For example, yeah, so okay, so one example of such a constraint that all look the same is you say this is the number of hours you need to make one of the products.
Yeah.
Okay, this is the total number of hours you need.
Okay.
Sorry, you have
exactly
available on the machine.
Right.
Okay, so it's
That's
an
one
example constraint. Okay.
But it could be that you can either, but it's not given in hours, but you say you can either make 100 of these magnets or 50 of these magnets or some combination of those. So you can take one magnet, 2 for the other magnet, and less than or equal to 100, which makes you not more than 100 of those, or not more than 50 of those, or some combination of the two. Right. Any more questions?
No.
So we'll next week we'll do batch planning, but using a dynamic algorithm.
Is this when we're going to get into dynamic arrays in